I think every person who comes to work for NASA dreams of being part of that spacecraft development program, that you get to see it launch and you get to see it send humans to the next step in the frontier of space, right? And I think every one of us started with NASA with that dream.
Okay, to start, first tell us a little bit about how you got here. And then if you could share with us who Monica is.
Okay. Well, I've been out here 12 years. I'm a research laboratory mechanic. They hired me on actually as general labor and said if I did really well, I had a chance to get into the NASA apprentice program. So I did really well and I got into the program. They sent me to school and then on-the-job training hours to learn the skills that I needed for here. And I guess the rest is history.
I'm Cale Yeager. I'm part of the Research Laboratory Mechanic Apprenticeship Program.
Okay, my name is Steve West. I'm a test facility coordinator here at SEC. Been here a long time. I think I'm on starting my 37th year. If you want to do the math, I think it's pretty close to that.
My name's Erin Reed. I'm a test engineer here at SEC.
I'm Nicole Smith. I'm the project manager for Orion testing here at NASA's Plum Brook Station. For the better part of the last 12 years, I've been working on some form of Orion with a slight detour to be a legislative fellow on the Hill for the senior senator from Ohio.
At the end of the 4 years that this apprenticeship is supposed to take, I'll come out as a research laboratory mechanic, have my journeyman's card, and go from there. I've always been a big space nerd, always been a fan of outer space and space travel and the big question of how do we get here. Just always been very intrigued by space. I'm inclined mechanically, I go with my hands. I like building stuff, troubleshooting. So it kind of worked out that I got to partner my skills with my desires and my what I enjoy.
I would say my main role out here is an operator, especially during test time. I run the compressors for the cryo shroud that changes the temperatures in the vacuum chamber. So, and offloads of liquid nitrogen and gaseous nitrogen.
I'm the contamination engineer here. So when I first got here, the facility has generally only been used for large-scale fairing deployments. And so they're not really clean. They're not meant to be in a clean environment. So the vacuum chamber that we've used has always been sort of dirty. And so when I came here, there was a big push to try to figure out how to clean the chamber and how to make the facility clean enough so that when we got a flight vehicle, we wouldn't contaminate the vehicle.
We are standing very high up in the Assembly High Bay at the Space Environments Complex at NASA's Plum Brook Station.
We have a vacuum chamber, environmental chamber that we provide the environment for space. We have the world's largest shaker table. We have the most powerful reverberation chamber, which is capable of producing 163 dB. The shaker table, that is for the sound. When you take a rocket and you pound it with the sound that makes when at liftoff. So there's a lot of capabilities that this test facility now has. At one time it was just the world's largest vacuum chamber with the world's largest cold wall. So it's much more now.
A lot of the technicians and engineers here are very hands-on and we have very diverse backgrounds. And it's really important to be able to take that diversity of experience and bring it here to solve problems. Like you'll have Monica out helping offload all of the nitrogen trucks. We'll go through about 12 to 14 nitrogen trucks a day when we're running the thermal vacuum chamber. You'll have Cale over driving the door. I think he's down there cleaning the floor right now. Everybody is hands-on and does a ton of different stuff. Erin Reed is an example of one of our test conductors, right? So she's going to be that point of contact in between the facility team that's running the vacuum chamber and the vehicle team. And then you've got the people who've been here for a really long time who manage a lot of stuff and make sure that all the gears keep going. So like Steve West will be managing all the technicians, where they're deployed, helping with all the operations. Sometimes you'll see him down here on the crane lifts. And then you have someone like me who's the project manager who makes sure that all these people have all the resources they need. I'll make sure that everybody working on the team knows all the information that they need to know. So we're just trying to tie it all together and keep everyone moving in the same direction.
We are all very diverse as far as our personalities, and we're all very accepting, and we all love to just have fun. I think that's probably the biggest part of what makes this team work, is that no matter what type of day you're having, no matter what type of work we have to do, we're always joking around, we're always having a good time with one another.
It's a tight-knit group that, I work with, and everybody's pretty accepting here. I do think it's cool for women to see they can break out of maybe a traditional job. That's a good thing.
I really like the people I work with, everybody I work with. We all work really hard, and it's really nice to know that when you're feeling overloaded with work, that the people next to you are just as overloaded. Misery loves company. But more than that, we're all working together towards a common goal. So there are lots of disagreements that we have, technical disagreements. We may see things with a different perspective, but we all know that it's because we're trying to create the best solution for what we're trying to do.
I mean, data's our product. We don't make any widgets or anything, so that's our product. So I believe the engineering and the techs here are outstanding. I would put them up against anyone in the world.
So the thing that's different about having Artemis here is that it's a real piece of spaceflight hardware that's going to be launched when it's done here. So we do a lot of other test articles to prepare. All of the other prior Orion hardware was development. So this one it's huge, and it's gonna go around the moon. And we're gonna be able to sit there and watch it launch and watch it while it's out on its orbit and see how it's doing and say, yeah, we had a huge hand in that.
I've been here so long that I've seen the transition, and it's so neat to finally see. I spent a lifetime getting it to where it is, and I'm really proud that we're testing flight hardware now. I think it's a credit to the people I work with. I work with some great engineers and great technicians, so very proud of what we've accomplished.
When it's a flight vehicle, you're not just concerned about the data from the test, you're actually concerned about the vehicle itself, because that's the thing that's going to be delivered to space. So that's when it becomes a higher risk.
During the thermal vacuum test, we'll provide a really cold background of space with our cryo wall, and then we'll be able to do different zones of heating to simulate being in a specific part of the orbit where one part of the spacecraft might be in the sun and the other part is in the shade. When we're done with the thermal vacuum test, we'll bring it back out, do some reconfiguration, and then put it back in that chamber, but instead of pumping the air out of it and putting the cold wall in, we'll actually hit it with radio frequency waves to do electromagnetic testing.
When you get in the test conditions and you got the chamber pumped down and the cryo shroud's at the temperature it's supposed to be, it can get very boring because everything's running perfectly, but boring is good. And to me, it's exciting. You're part of the crew, you're part of history, really, so I think that's very neat.
We face challenges almost daily, which is part of why I love this job. I mean, we don't do the same thing every day, we do something different. We respond to changes. Everything we do is schedule driven for the most part, so when schedules delay or we have to redirect, and that's a challenge in itself. But we keep our crew working very effectively all the time, which is a challenge, and I get excited about those things.
I think the biggest risks are for your optical components. For instance, we have a star tracker on the vehicle. So if you can imagine if a particle of dust or some bit of oil got stuck on the star tracker and the computer sees it as a star, but it doesn't move no matter how the vehicle moves, that would change how it's going to try to navigate, and it might even mess up some of the algorithms. So there's a lot of those sensitive surfaces that we're concerned about.
If something gets contaminated with the spaceflight hardware, it can be detrimental when they go to launch it. From the oils from your hand, anything can gas off going into space. You're contaminating the test article that's coming if you touch it with your fingertips even. So we have to be that careful because it is spaceflight hardware.
Outside of work, I have a 4-year-old son and 2 8-month-old sons. We had twins over the furlough, so that was exciting. I'm lucky. My girlfriend is very supportive. She helps out a lot. She makes it easy. Having the twins at home is very tough because she gets run ragged. I get home just in time for bedtime. Luckily, as far as school goes, I'm doing online courses this time around, and hopefully we'll be able to complete just through online courses. But yeah, it's definitely tough to balance it. It's very tough.
So it takes someone that's motivated to try to get it all done. And sometimes I have to sacrifice a little bit one way or the other, you know, because I do have a family. But I love this job. My kids are happy I work here. It's just a good thing. And it's very, very exciting.
It's huge for me to be a part of it and to see the spacecraft come here to Ohio and be tested for 4 months and then see it launch. And I'm really excited about people going back to the moon. So the idea of the first woman stepping foot on the moon and me getting an opportunity to work on this spacecraft here, it's huge. So I'm really excited for that.
Like, wow, yeah, it's really coming to our facility. This is history. This is pretty cool.
I think it means everything. I think this is the next small step in humanity's exploration of the universe. You know, because this is going to help us not just get to the moon and not just get to Mars, but then it's going to be the jump-off point to the next place we go. I really feel it's a really awesome thing to be part of. We are taking that next step. We are doing that next great leap.
You think about all of the thousands of people who worked on this vehicle and worked on all of its testing. I'm such a small part of this program. I'm not even a blip on how this program functions, but it takes all of those people to make something like the Orion vehicle at Artemis successful. And so I'm happy to be a part. If that's the part I need to play, I'm happy to be a part of it. So it's exciting.
Well, I'm a real go-getter. I like to go, 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 which helps me for this job because we do put a lot of hours in. I used to be in the apprentice program, so I was going to school. At the time, I had 3 younger kids. That's me. Yeah.